Good morning, guys. And I'm continuing with thermochemistry. And this week assignment, as I talked earlier, will be focusing on calorimetry and the heat, also referred to as enthalpy. And this video particularly will be focusing on calorimetry, and there'll be a virtual lab that you guys have to do, which is for completion for 10 points. So this is the lab, this is the Google form I'm talking about. And after following my video and the slides, you should be able to complete this lab and submit for points. So I've already talked to you about the practice problems that was on the previous slide, so you should be all aware of that. And you should have done it, followed the equations of Q equal to CPM delta T, and done your practice problem, then turned in your assignment. So basically, watch the video. There are additional resources that I'm going to add towards the end of the slide that you can follow the Ed puzzle if you're not clear, and then turn in your Google form. This is the Google form that I'm talking about, the virtual calorimetry lab that is for 10 points. So let's talk about what is calorimetry. As you can see, I'm breaking up the word calorimetry. It is made up of two parts, calorie and metry. Calorie means like energy and metry means measurement. So basically we will be measuring the energy, and the equipment or the apparatus that measures the energy is called as a calorimeter. There are different types of the calorimeter that are used. The one that I'm showing you here is the high precision calorimeter that can be connected to the computer and records the temperature changes. The one that is commonly used in the lab is the simple coffee cup calorimeter that we insulate with a styrofoam cup, and we measure the temperature differences. Whether this is the high precision calorimeter or a simple coffee cup calorimeter, the function is the same, both of them measuring the temperature difference. So let's review some terms. Heat is the transfer of energy when two objects are at different temperatures. The symbol being Q, the units being joules. It is the same thing as the enthalpy. The symbol being H or the delta H, that tells you the change in enthalpy. So Q, H, and energy are all measuring the same things. They're the symbols that can be interchanged. And in this lesson, we'll mostly stick with Q. Then is the specific heat capacity, that is the CP. That is, if you go back to the previous slide that I mentioned you and we did the calculations of CP, it is the amount of energy needed to raise the temperature of a substance by 1 degree Celsius, and it is specific to the substance. The specific heat of water being 4.18 joules per gram degree Celsius. And remember, like in the last week lesson, we talked about more is the specific heat capacity, longer the substance takes to heat up, and longer it retains the heat, like water. So we will be using the calorimetry to determine the identity of a metal. So for that, what we'll be doing is we will put the metal into the boiling water. We set up the lab, and as it is the boiling water, so the temperature of the metal will be 100 degrees Celsius. We all know that the water boils at 100 degrees Celsius. Then we set up our foam cup calorimeter and record the temperature of the water, here the temperature being 30.2 degrees Celsius. We also record the mass of the water. All these recordings have been noted in the data table. Here, the mass of the metal being 56.76 gram, that was taken before we put that metal in the calorimeter in the hot water bath. And then we take the mass of the water that we have used in the cup. Initial temperature of the metal is 100 degrees Celsius because we had already put that in 100 degrees Celsius. And final temperature of the water is 30.2 degrees Celsius. No, sorry. Initial temperature of the water was 30.2 degrees Celsius. That is before we added the metal block in the calorimeter. Then what we do is we put this hot metal in the calorimeter, and of course, as you know, the metal is hot, the water is at 30.2 degrees Celsius, so the metal is going to give the heat to the water, and the temperature of the water is going to go up. In this case, it has gone up to 32.5 degrees Celsius, and we record that too. That is the final temperature of the water. So all the temperature changes have been recorded, and all the masses have been recorded. The mass of the metal, the mass of the water, the temperature of the metal before, the temperature of the water after. Now, the most important thing here is that what was the final temperature of the metal? Now, you know that the metal transfers the energy to the water. So once the metal and the water reach the same temperature, energy transfers from the metal to the water stops. The thermodynamics equilibrium is established. So we assume that the final temperature of the water and the final temperature of the metal are the same. So here if you see that I have not given you the column for the final temperature of the metal, because we are assuming that the final temperature of the metal will be the same as the final temperature of the water, that is being 32.5 degrees Celsius. That's what you see here, 32.5 degrees Celsius. Now, what was the delta T for the metal? As you know, and I discussed it earlier, the delta T is the final temperature minus the initial temperature. Please note whether I'm looking for the metal or for the water. Here I'm looking for the metal. So we'll subtract the readings of the metal, the final and the initial. The final is the same as of the water, in this case for the water. Initial, remember we started the water with the boiling, started the metal with the hot boiling water. So the temperature of the initial temperature of the metal was 100 degrees Celsius. We subtract the two and we get the reading 67.5 degrees Celsius. Here you can clearly see that the delta T is negative, and it is okay to have delta T as a negative value, saying this reaction was exothermic. Heat was given out by the metal to the water. Now, what is the delta T for the water? Again, please note, now are we looking for the water or we are looking for the metal? In this case, we are looking for the water, so we'll take all the values of the water. The final temperature of the water minus the initial temperature of the water is going to give you the delta T for the water, TF minus TI. And the values here are the final temperature of the water being 32.5 degrees Celsius, and the initial temperature before we drop the metal, hot metal in the water was 30.2. We take that reading and we do the calculations and we get 2.3 degrees Celsius. Please see that this value is a positive value. That means it is an endothermic reaction. The delta T is positive because the water absorbed heat that was given by the metal. Now we calculate the heat change, that is the Q for the water. Remember the equation that we reviewed in the first presentation, that Q is equal to mass times the specific heat capacity times the change in temperature. Change in temperature being TF minus TI. For the water, heat capacity means the specific heat for the water, that is being equal to 4.18 joules per gram degree Celsius. It is a constant value. It depends upon the substance. For the water, it is 4.18. 4, or you can use 4.18 for a reference, joules per gram degree Celsius, and mass is for the water. So we take the mass of the water as 358.30 grams. The change in temperature of the water, the final minus the initial, and the Cp for the water for equal to 4.184. We plug in these values. Here we go. The mass being 358.30 grams times 4.184 joules per gram degree Celsius for water, and the change in temperature, the final minus the initial for the water, and we calculate the Q for the water being 3,448 joules. Remember, the units for Q is the joules, the uppercase J. Now we'll calculate the heat change for the metal. This is based on the first law of thermodynamics, and that is the energy lost by the metal is the same as the energy gained by the water. So we already know the Q for the water, that is being plus 34 3448 joules. That was a positive value and it gained the heat. That will be the same amount as the heat lost by the metal, only the sign will be different as the metal loses heat and the water gains heat. So Q for the metal will be equal to a negative Q for the water. So here it is, negative 3448 joules. Remember, heat gained is the same as the heat lost. So the amount remains the same, only the sign changes. Now we'll calculate the specific heat capacity of the metal in the trial 1. Remember the equation that we learned in the first video, that Q is equal to mCp delta T, m being the mass, Cp is the specific heat, delta T is the change in temperature. We rearrange the equation to calculate the Cp. Cp is equal to Q over m delta T. We plug in the values for the metal. Again, please note the metal or the water is being asked. So we plug the so the Q being negative 3448.2 joules is uppercase J, sorry guys here, and M being the mass 56.76 grams, and times it by negative delta T, that is 67.5 degrees Celsius. That is the change in temperature of the metal. And we get the value for the Cp be equal to 0.91 joules per gram degree Celsius. So this is what we got from the water, only the sign has been changed. This is the grams of the metal, and delta T of the metal was this value that we got 67.5 is the initial temperature of the water was 100 degrees Celsius and the final temperature was 32.5. We remember we take into account that the final temperature of the metal was the same as the final temperature of the water, assuming that they both reach thermodynamic equilibrium. That's how we got 67.5. So it is basically 32.5 minus 100 degrees Celsius. So Q for the metal we know, M for the metal we know, delta T for the metal we know. We plug in, we solve, and we get the value for Cp for the metal. I'm re-teaching this guy. So this is the what that we subtracted, and that's how we got 67.5. Remember always the delta T is Tf minus Ti, and the Tf was here lower than the Ti. Now finally we'll figure out which metal has been used. So we know that the specific heat capacity is specific to the substance. Here the specific heat was calculated as 0.900 joules per gram degree Celsius. So we look at our data table, our known values of different metals, and we figure out that this guy matches with aluminum. So the specific heat of the metal is 0.90 that matches with aluminum. If we have a multiple choice question and we have to figure out which metal was used, we can go ahead and circle aluminum. So please remember the specific heat is specific to the substance. No two substances can have the same, exactly the same specific heat values. So I thought um, not I thought, like I'm thinking that this presentation will help you to go and do your virtual lab. Please go over your slides and look at the virtual lab here, that is in the form of a Google lab form, and submit that for points. I have also added um, your the Edpuzzle resources for you. that you can always look at and review your how to do the calorimetric problems and solve them if I haven't missed anything, or you're having trouble following the PowerPoint or need more additional resources. And of course, Bozeman is my guy. He does an excellent job in going over all the enthalpy of the reaction, the calorimetry, and in you can stop in between and answer the questions so that you can follow how long or how far have you understood this presentation. Also, this is you can follow it with Professor Dave. That also same concept in different forms and different questions. You can also follow the different questions and see how many are you getting wrong, and then you can always correct them. This is another red puzzle for you for your resource. Make sure you turn in your virtual virtual lab form, and you can do it as many times as you want before Sunday. This Sunday, that is the May 3rd. Whatever grade I get by May 3rd will be your final grade for the assignment. Thank you for watching and listening to my videos. Let me know if there's any other way that I can improve. And if you have any questions or concerns, please shoot me an email and I'll be glad to help you out and have host a Zoom session so that I can explain the concept again. Thank you.